All right, so you guys need to know some reciprocal trig functions. Okay, so secant of theta is 1 over, and then you're kind of saying that with a question in your voice, aren't you?
It's just because it's so backwards.
Yeah.
I always question myself a little bit.
Good. So the thing you have to remember is that there's no justice in the world. And the one that starts with S, of course, goes with the one that starts with C. So secant of theta is 1 over cosine of theta. Cosecant of theta is, of course, 1 over sine of theta. And cotangent of theta is, of course,
1 over tangent.
Cosine over sine.
1 over tangent of theta, which is, of course,
Cosine over sine.
cosine over sine.
Well, that's what helps if you order them the first two with the cosecant and then secant. It helps you remember because you usually have sine, cosine, tangent in your head.
Oh, okay, sure.
No, it doesn't matter.
Cool. This is what I want you guys to know about these. The other thing I want to convince you of is that these are useful for something. So secant has a super cool thing. Secant has actually 3 super cool things. It has, let me see, so let me give you another word. So the graph of secant is called a catenary. Trust me. So it looks kind of parabola / half circle-ish. It's closer in some senses to a half circle than it is to a parabola because it has vertical asymptotes. Why does this have vertical asymptotes? Yeah, because cosine can be 0 sometimes, right? So this thing should have vertical asymptotes on it somewhere.
Oh.
You guys cool with that? Okay, so catenaries have cool things about them. One of the cool things is if you can make a catenary in real life by pounding 2 nails into a board and then hanging a piece of cable between the 2 nails. Cool? Thing 1, civil engineering thing. If you're hanging cables, they always come in catenary curves. You guys drive by catenaries a million times a day. Because we hang cables from poles a lot for some reason. Cool? And those catenary curves, right? Sometimes they look like this and sometimes they look like that. They're still catenaries, they're just vertically smushed, right? And the vertical smush factor for power lines depends on what?
The tension. The kind of cable.
Yeah, the tension, which depends on why do we hang them from?
Distance between poles.
Yeah, there's a whole bunch of things, but the one I want to get at is temperature. That's why we hang cables from poles.
So they stay cool.
So they can stretch and compress without it being a pain in the ass. You guys see that? Because they're made of metal, right? Metal changes a lot in length depending on temperature. So it's more convenient to hang them from cables than it is to like stretch them tight along the ground. Because if it got colder, they'd pull in
Break.
and pop off the ends or break or whatever.
So is there a certain tension that they always have to be put at?
Yeah, I'm sure there is. I don't know the specs.
Oh, okay.
Yeah, I expect that for different gauges of wire, there's like the drop in the middle versus the width you run. So that's one of the things about catenaries. The other thing about catenaries is that the area underneath a catenary is the arc length along it.
You have to drop them out.
So if you put an x-axis on here, the arc length from here to here,
Does that trough not touch the x-axis?
this guy, yeah, it doesn't touch the x-axis,
Okay.
is the same as the area under here.
arc length was like 5 units, the area would be 5 units squared?
Yes.
Awesome.
Yeah, catenaries are super bizarre. That's really cool. So those are 2 cool things. And the third cool thing is you can make a smooth rolling square with catenaries.
What?
A smooth rolling square.
Like his unicycle that he.
Yeah, so if you go look at my personal YouTube channel, there's video of a square wheeled unicycle that I made. So you make a track out of a bunch of catenaries.
Oh, okay, I see what you're talking about.
So you cut a bunch of catenaries like this. And if you do it right, you can make it so that when you roll a square across, the center of the square stays the same height.
I've seen the video.
So this is cool.
So you need a track though in order
Yeah.
to write it.
Yeah, yeah. Well, because otherwise it's a square.
Well, yeah.
And if you add if you make it roll smooth, then it's going to be
A circle.
a circle. You guys cool with that? So those are 3 cool things that smooth rolling. Actually, you can do that with other shapes. It doesn't have to be a square,
All right.
but a square is kind of the easy one. Cool. So if you take Calc 2 from me, we'll do that as an exercise. Cool? Yeah. Yeah, I'll bring it in. We can ride it. It'll be fun. There'll be broken bones and tears. It'll be cool. Cool? Questions, things about this? Basically, remember what?
Squares can ride.
Not that. The thing I want you to take from this is not that. The thing I want you to take from this is that secant is cool and it's 1 over which one?
Cosine.
Cosine. Cool.
Starts with C.